Is that what you started off with?
Yeah, and there's the final version actually is going to have a really big surprise for everybody that plays it.
Cool.
I'm not going to tell you what it is. Uh,
So we'll be able to play it on the simulator then with the Dazzler there because I
it'll
don't have a Dazzler board.
it plays on an 8080. Yeah,
Okay.
yeah. It works on the simulator. It
Okay.
doesn't. The thing is, it's it works on the Dazzler II. Both
Yeah.
of my Dazzler II boards, the colors went out. The only
Yeah, I
colors,
saw.
yeah, one of them has
Yes.
just
Go ahead.
blue and black, black and blue, and the other one's black, green, and blue. The red is gone,
Yeah.
the yellow's gone.
That's messed up. Yeah, I saw you posting about that. I don't know enough about that's why I didn't jump in. I don't know much anything about the Dazzler. It's not something
Well, it's a
I,
Dazzler
I
2 board.
yeah.
Yeah,
Yeah, so it's the one. It's the one that's you can get boards from Todd, and I think you had to get pals and stuff from him as well, right? To have it
right,
done.
yeah.
Yeah, yeah.
So, yeah, it's
I
kind of a
haven't done
bummer
that one.
that those things quit on me.
Yeah, that's odd. Yeah, I know you had some other problems with stuff, and I think you figured out what that was. So you got the machine booting again for yourself, right?
Yeah, it was the original Dazzler Reproduction Dazzler board set that one chip fried on it, and I don't know why, but that chip failed, and it wouldn't even let the computer boot. And
Wow.
Peter Higgs said that that chip only dealt with something in the video and that, but apparently it affected other signals on the board. But once I
Yeah.
replaced that chip, I tested all the chips on the second board. It was not the first board was just all video graphics. And the second one is the one that connects to the bus and stuff.
Yeah.
And so
Yeah,
I tested all the chips.
all it takes is a bad a short or a bad signal on any one of the buses, any one
Oh
of the
yeah.
S100 pins, and the computer won't run right.
Yeah.
Yeah.
Well, the thing is, this chip was at the top of the board, and and like Peter said, it didn't have anything to do with the S100 bus. It was something in the video signals
Yeah.
going to the
Right, but
other board.
Yeah.
it was probably driving a bus driver or something that was locking it in a weird state.
Yeah.
Yeah,
Well,
Yeah,
could that
well,
could
that's
that
it. When I put a new one in, put the boards in
yeah.
the computer, boots fine, works great.
Uh-huh.
Okay. But you mentioned it does video. Is that could that be the cause or possible link to what your video color problem is now?
Well, no, the video color problem is with the Dazzler 2 boards. This
Okay.
is on
So
Dazzler 1 boards.
oh, okay. I didn't realize you had both. Okay, I didn't realize just realize you had
Yeah,
the original
I've
Dazzler.
got 3 sets of the Dazzler 1, the original Dazzler,
Yeah.
and 2 Dazzler 2s.
Well, you could
So the
feed yourself for a
Dazzler
few
2s,
months selling those. Those original Dazzlers are going. I see seeing for 12, $1,300
Yeah. So that's
on
the advantage
eBay.
that's the advantage of using a simulator. Ships don't fail.
Yeah, there you are.
I still think somebody that knows enough about the electronics could figure out how to take the DHansel terminal for the Altair Arduino Pro. That Dazzler terminal puts out a signal as clean as the Altair simulator does.
Yeah, well yeah. It's
I
not
mean,
driving an old school video display. That's part of the reason. So all of the
well,
circuitry,
yeah, it does VGA. It's
it does
VGA.
VGA. Oh, okay.
Yeah, it's VGA out, but it's as clean as. I mean,
Yeah.
the only artifacts are whatever problems you have with your monitor.
Yeah.
But the Dazzler one boards, they, you know, like one set I have always has a yellow background. So that's probably another chip or something
Yeah.
on
Well,
that.
you remember how long it took me to get those running
Yeah.
for you? It was quite a bit. Everything had to be working just right for it to work good. And I finally got them both working, but it was a pain in the ass.
Yeah. Well, I'm sure it's a lot of it's analog circuitry, right?
Oh
It's
yeah.
it's old school or video generation as opposed to anything modern that does VGA is doing it all digitally.
Well, it does it almost all digitally.
Oh, it does. Okay.
Yeah, I mean the analog, is a section that's analog, but all the clock generator and all
Hmm.
the logic
Yeah.
up until the resistors is pretty much all digital.
Yeah, it's two boards full of TTL chips.
I
I mean,
say that. Now let me look at it again. I've been through so many different boards, it's hard to remember.
Yeah.
And especially between the Dazzler and the Dazzler II. Well, that's right. It won't be on Monahan's thing because it's the original Dazzler we're talking about.
Yeah.
Might be probably find it on Mike's site or something.
but
Or someone
if
else.
somebody knows enough about electronics, they could take that David Hansel's PIC-based Dazzler thing and an Arduino chip, put it on an S100 board, and make a Dazzler that outperforms the original and the Dazzler II. I mean, because it's just an Arduino chip and a PIC chip that are making that Dazzler board work. I mean, it
Yeah.
works, and it's awesome display. Nice, clean VGA output.
Mm.
Is
And
that
that's
is
on
that
the
you're
Altair
trying
Arduino? Okay.
Altair Trino? That was I was going to ask the same thing. Yeah.
Yeah.
Yeah, it goes from the Altair Arduino to David Hansler's Dazzler terminal. It's just an external terminal board.
Okay.
Um, I got it in a little plastic box there.
Yeah.
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 And I mean the signal from it, let's see, of course I'm not running
Yeah.
software on the other computer. But anyway, yeah, it's just a little 4-inch by 4-inch board, and it has awesome video output.
Yeah.
And you get to use two
Oh, the
joysticks.
joysticks. There you are.
Yeah.
Uh-huh.
So you get two joysticks on the thing, and it run,
Okay.
so and the whole system just runs on, like 5 volts.
Right.
So it seems to me that would be the smartest way to make a Dazzler board today
Yeah.
is, I mean, who cares if it's the electronics, putting that together on an S100 board, and then
Well, yeah.
getting the software to the firmware or something. You'd have to do something to have the firmware and the Arduino talk to the S100 bus as the Dazzler.
Yeah, I don't know enough about it, Walt. So I mean, it sounds. I always think the same thing. It sounds easy in our minds, but I think there's always some gotcha there that we aren't thinking of.
Ain't that the
Well,
You
truth?
know?
but what I'm saying is, if it's running on Arduino code, which is open source, all that's available. All the Dazzler stuff is open source. Somebody that knows the electronics can do the electronics part, and the
Yeah.
You're right about the open source part makes a big deal. It's great that they're offering it up, so you could look at it, and there might be a
Right.
possibility of getting it to work. But again, it's got to be you have to
Well, it
find the
runs
person who has that
Dazzler
electronic
software.
knowledge.
But
No,
Joe, it
yeah,
runs regular Dazzler software. So
oh yeah,
all you're doing is connecting that part of it to the S100 bus.
So all you
like
need
I
to do
said,
is track down somebody who's interested in Dazzlers and have them design
That's
it.
the Dazzler
And that's the
knows
hard part.
electronics.
That's the problem is
Or
everybody.
you'll have to learn the electronics so you can do it yourself.
That's retirement's for, man. You got to go and
Yeah.
you start learning stuff like that. You
Oh
started getting
man,
to
Hell yeah.
assembler. You started doing some assembler. I didn't think you always kind of never
no,
touched it. Now you got some
Claude's
going.
doing the
Yeah,
assembler.
but but if you take a look at it, you can probably start learning some of the stuff that Claude did,
Yeah.
and try to make heads or tails. That's what I did. I mean, I used some AI a little bit on and off when I was doing my Jomon thing, and so then I realized I can go through and make changes myself, and it
Hmm.
just takes time. I mean, it's definitely time. It's an investment, but everything's written. You do it if you can do it in assembler, and I was doing all 8080. I haven't done any Z80, which will be my next
Well, see,
thing I'll start
Get
touching
ready.
at.
that's what I'm having Claude do is all this Dazzler stuff in 8080 code because the original Dazzler software was all 8080
Yeah,
code. It wasn't until they hired a contractor who
yeah.
changed over to Z80.
Yeah. Joe, when you start working Z80, get ready to be very confused. Because
Is it?
all the mnemonics change. Because
Yeah.
they didn't
Yeah,
want to use 8080 mnemonics even for the same instructions. And you'll
yeah.
find yourself constantly typing in the 8080 mnemonics and getting the assembler going, "Ugh."
Now isn't there I think there's an assembler out there that a
There probably
Z80
is.
assembler that
Was
uses
it
Z80 code.
ZMAS or
Yeah.
ZAMS? Wait, ZASM. Sorry.
CASM.
Yeah,
Yeah, they have an
ZASM.
online one, and I
Mm.
actually run that's how I actually compile Jomon. That's the
Yeah.
somewhere I'm
Okay.
using. But yeah, so it does have an option to convert it and everything for you.
Oh, okay.
Yeah,
Cool.
for me, I've just been running since the 8080 will run at
Hmm.
least, I guess, really close on Z80, and since
Oh,
it's
it's
just a
perfect.
monitor
It's perfect.
program,
Yeah.
yeah, it's just been working. So that's why I went 8080 in the first place.
Yeah, I mean, essentially, the Z80 is just a superset of the instruction set. They just added instructions. So
But
every 8080 instruction is in the Z80, just not
yeah,
the other way around.
yeah,
Yeah,
Yeah.
you'll be happy with all the dual registers, which are really
yeah.
great for interrupt driven stuff, and relative jumps.
Right.
Oh
Relative,
yeah, okay.
relative absolute jumps was the biggest pain in the ass.
Yeah, you got that was a limit of is it 128?
Yeah,
There's a limit. Yeah,
plus or minus 128
yeah, that's it. I think
from where
minus.
you
Yeah,
are.
yeah.
Yeah.
Yeah, Bob Emmerman, he keeps telling me he wants to stick with Z80 code for the Dazzler. And I'm going like, yeah, well, Claude's doing fine with 8080. So I've got, half a dozen assembly programs out of Claude now to do
Yeah.
stuff on a Dazzler board, and it's all 8080 code.
Yeah.
See, there is your problem though. You're cheating, Walt, by using an AI. You're supposed to be doing all the assembler code yourself.
Yeah, but I don't know assembly language.
Well, that's the only way you learn.
I barely learned basic.
That's the only way you learn.
Yeah,
Yeah.
the
You don't learn by
use
having an AI do it for you.
you can use AI as a tool to kind of help
Yeah,
you
but
along and ask for examples, and then you plug those examples into
well,
your
I was
code.
doing that. I was doing that, trying to learn
Yeah,
assembly. But that's, I wouldn't have a half a dozen Dazzler programs today if I was just waiting till
yeah.
I
No, I
learned
get you.
assembly.
Yeah. Have you ever messed around with the like BASCOM, the basic compiler and stuff? So, I mean, that would at
Well,
least give
yeah,
you some
yeah,
performance.
it makes a big difference on some programs, but other programs it doesn't really matter.
Yeah. Well, sometimes if it's a timing thing, yeah, that'll mess you up anyways. You run it in basic, it runs one speed, and then you compile it, and everything's just, you know.
Yeah. Yeah. Timing loops based on processor speed. Yeah, that's death on a stick.
Yeah.
Yeah.
It was a beginner mistake, though. That's a lot
Yeah,
of people
we
will do
all
that.
do it.
I
We
think
all
it's
do
working
it.
perfect. Yeah.
We all do it, but yeah.
That was one thing that Chat GTP, when it first started using the W command in DZM basic, which is a wait,
Mhm.
and you give it a number how many milliseconds to
Mhm.
wait. Well, ChatGTP thought, okay, this is milliseconds, and so it said wait like 50 million milliseconds, before you do something.
That's a mistake that's been brought on by Arduino.
No, that's not on Arduino. That's just DZM Basic.
I know, but I'm saying people have used that, have gotten to use that because of the Arduino Millis and whatever the other one is.
Yeah.
Oh,
there didn't used to be a standard. It didn't used to be you could just call Millis open paren 100 close paren and have it do a millisecond delay or microsecond delay or whatever.
Yeah. Well, it turns out the W stands, the number after it is a second, not a millisecond.
You're waiting a little bit there, Walt.
Yeah, when the programs were working, I'm going like, what the hell? I jammed my computer to a halt and that.
Yeah.
But as soon as
that's where you're reading the manual.
well, no, it was I saw the big giant number in the code, so I just knocked it down to 0.5, and then it was fine. And it's kind of funny, but I don't know how ChatGTP figured out the thing was milliseconds.
Well, I mean,
I think that's what Terry was mentioning. Is that it's looking what the Arduino people were doing and kind of.
Well, no, I gave it the DZM Basic manual in plain text, which explained how each command works, and for some reason, I mean, maybe it was, something left over from some Arduino thing that it learned somewhere else.
So I don't know about those computers or those printers, but on a teletype, if you get a ribbon without a rivet in it, you can just tie a knot.
Yeah. Well, instead
that knot catches that arm as well.
Yeah. Well, what I did instead was I put the ribbon in without the eyelet.
Yeah.
And ordered some with the eyelet so I don't forget.
Yeah, I have to remember that knot
trick.
Reverse
them until I learned the knot trick. Yeah,
I'll have to remember that because I can't remember if I got the eyelet in the ribbons I have or not. So
yeah, it's really hard when you go on like Amazon or whatever to figure out which ones have the eyelet and which not, because most people don't care because they sell them for typewriters, and I guess in typewriters it works somehow differently on a lot of typewriters.
But does that knot in the ribbon work on the ASR 32 and?
Yeah.
Oh, okay.
Yeah, I don't know if it works on new printers. I know it works on teletype.
Right. Yeah.
Well, I found it interesting stuff to look at and demo if we run out of stuff to talk about.
Yeah.
Sure. Please. I'll get this one out of the way. So these are the SIO boards, the first production one from JLC PCB.
Looking forward to that.
So sent one to Tim. Yours went out yesterday, and Mike, this is yours. It'll go out tomorrow.
So I could have used one for the demo tonight.
Oh, well, you'll have it later this week.
Well, what does that have for RS-232 drivers? Max or 1488, 1489?
Max.
Yeah, because the IO4 doesn't have standard RS-232 receivers, and I just found a place where that becomes an issue.
Okay. Yeah, it has this has Max and TTL, so you can put whatever you want on it. But
one of my videos, I made this passive board that allows you to combine a video terminal and an external paper punch reader onto one port, just like
a
but that doesn't work with an IO4.
Oh,
electrically. It's not happy because it doesn't have the right negative voltages, and it just doesn't work the same as everything, quote, official RS-232. But anyway, so I had to use an AB switch instead.
Oh, because it's okay. Doesn't the JP board have a bunch of drivers for everything in its uncle? It's the two SIO.
Yeah, it's got 1488, 1489s, and current loop and DTL jumper options. Yeah. No, but it all works fine. I've never run into a problem with this board before. But yeah, I just found one. No, but anyway, so two people have been asking me to help them with some very early Altair restorations. And one of them came with a 88 PMC board. That's the 2K EPROM board that has spots for 827 or 1702s, the little 256 byte EPROMs. And there's two of them on there, and he didn't know what they were. He wanted to know, he wanted help burning, floppy disk, or the DBL prom, the multi-boot loader, turn them on. He wanted those on there. But these were down at the low end of the memory range on that board. He didn't know what they were, so he sent them to me. And I disassembled them I've been away on trips for the last few weekends. So on the airplane, I entertained myself and disassembled them. And it goes right along with a bunch of my videos where it talks about how people just did both hardware and software just to make their systems do stuff. So this is a very early thing before the multi-boot loader even existed. So in the beginning, you had to toggle your bootstrap loaders. The multi-boot loader came along, which made that simpler. You didn't have to do that anymore. Well, that started with version 4 of BASIC. But he did all this to work with version 3. And Walt might like this. He bought, so this guy was using SIO. Well, actually, no, he made his own board that looked like SIO as far as the output and the input. And then he bought a VDM board when it first came out. And he wrote an EPROM that allowed him to switch between his console, which had to have been hooked to a teletype, or the VDM board with sense switch 0 on the fly. Just a perfect example of somebody who was pretty good with stuff, making a system. And so, yeah, I was going to demonstrate that tonight when we run out of stuff.
Cool.
To talk about.
When Mike's doing this demo, you should mute your mic buttons, because in the video, other faces kept popping up over the demo.
Okay, we'll do that.
Yeah, we can do that.
Yeah, no problem.
Can you guys hear me?
Yeah, okay.
Can you guys hear me?
Yes.
Yes.
Yeah, Mike, we hear you, bud.
All right. Let me share my screen. First, none of this will be on the screen after this. So, Walt, you shouldn't have to worry about anything. I must have browsed away. I had this all ready to go. All right, so here is the guy's board. All right, so this is the 88 PMC. It's got 2K of EPROM, as 8 1702s, and he has these two down here at the bottom, which is not typically where the MITS ones are. They're up here at the top. So this is an F800, this is an F900. This one with the phi on it does one function, and the one with the 13 is basically the output driver for the VDM board that I was talking about. So that's what those two EPROMs were that he gave me. And then the phi EPROM ends up being nothing more than two of the disk boot loaders. The bootstrap loaders. One is for extended basic version 3.2, and the other is for 8K basic 3.2. So this tells you this was before 4.0. This is before they had their multi-boot loader technique. And so you had to do it on the front panel, or this guy just took it upon himself. And this is the exact same code that is basically in the, of course, except it's an F800 instead of a 0. So he just put these, that's the whole EPROM. So, that first EPROM, this is the phi EPROM, doesn't have much in it. So if I want to load extended basic, I'll jump to F800. If I want to load 8K basic, I'll jump to F814. And that just saves you having to type in the bootstrap loader. The other EPROM is what I found cool. So this is an output driver where if sense switch 0 is down, the output goes to the SIO console just as always, and that's probably his teletype. So sadly, it takes him 20 minutes to load extended basic, 12 minutes to load regular basic, but then he can turn on his VDM1 and just use the keypad on his teletype and no longer have it 110 baud for everything on the way out. And yeah, this assembles into the original EPROM. Now, once you start it, you do have to patch BASIC in order to point it to this EPROM, and I'll show you that. All right, so I'm gonna switch over to my phone. I guess I can leave that up, not that anybody cared. Go ahead and zoom in on the phone. Let's see. I don't even see what I'm looking at. How do I?
Turn your phone mic on. Mike, turn the phone microphone on.
There, is that working?
Yeah, now, okay, now we can hear you.
So none of it came through, huh? I can't even
Yeah.
get video back.
Yeah, we're looking at you now.
I have no clue. You got my side view. There's me. Oh, there's my front camera. All right, so can you hear me?
Yeah.
Fuck, I lost audio again.
Oh no, we hear you.
No, we hear you.
Good Joe. Okay.
No,
Good.
his phone.
Okay. So can you see the computer in front of you? And you
Yeah,
can
but it's just a little tiny postage stamp because
No,
your desktop share is on.
no, you can swap it. There's a way of switch with
Double
shared
click on
content.
the small image, Walt, and you can see the big image as your screen.
I'm trying that, but it's not giving
Yeah,
me.
And that only works when there's screen share. Now that when the screen share's not there, you're back to normal. And you can set it up for, let's see if I can remember how to do this. It's the view, you change the view mode for Zoom.
Well,
Then
it's
you,
a speaker. You change it to speaker. That's why I was saying is if everybody has their microphones muted, then we
yeah.
don't get those background things where faces.
everybody did that, but then I asked everybody to talk so I could hear them. Okay.
Okay, I'm turning mine off.
Can everybody see the computer? Okay. All right. So this is Altair CPU. Technically, I could put in an 88 PMC and some RAM. I'm just using the Flex 64. This is the VDM1. This is that 2021 version where it's got the connector built in, but it's identical schematic. And then I'm using an IO4 for an SIO. So his system was a VDM1 board, CPU. He had 20K of RAM in it. So yeah, he either had 5 4K boards or he had a 16K and a 4K board. And he specifically coded this to work with 20K because he put his variables at the very, very top of the 20K boundary. All right, so if you wanted to boot BASIC, you would just turn on your computer, examine F800, for example, to boot extended BASIC, which was an F800. Now in version 3.2, to boot through the SIO, all sense switches should be 0. And then you'd put your paper tape into the teletype and you'd hit start. Rather than wait 20 minutes, I should be able to do this from the Terraterm 9600. Oh, that's not a good. Oh, I didn't hit run. We're still wait. Except now there's going to be garbage characters in there, which will throw it up. So now we need to do that again to be safe. That's typical of the old stuff. Okay, so now it's running in the EPROM. You can tell. Normally you would just see this because it's running at 0, but this is running the EPROM. So now I can send the tape. All right, so that was when the tape got past the leader and jumped to the checksum loader. And then when the checksum loader is done, now I have an A/B switch up here. I don't know if you can see it yet. It's in view. So I have to switch back to the terminal now because I couldn't use my little Y adapter thing. All right, so the terminal we've booted and it was asking for memory size. Now, in the old days, you would put, maybe some custom code you wrote, or for example, all the accounting software had drivers for the Centronics printer up in high memory. And so you would specify a value less than your total memory to make sure that that top spot of memory was not eaten by BASIC. So I haven't put a big enough program in to ever clobber it, but to be safe, for his use, he would have typed in 2470 or so. That saves the upper 6 bytes of memory or a little bit more. I just added a few extra bytes to be safe so that BASIC won't touch where his variables are stored for that EPROM. Again, this is a 20K system, so this is just right below that where he put his variables. Terminal width, want signs, cosines. All right, so we're just up and running extended BASIC version 3.2. That would have taken 20 minutes, but we did it with a 9600 baud teletype instead. Okay, so after you've completed this, obviously BASIC knows nothing about this EPROM he wrote where he put this VDM driver, right? So you're going to have to use the front panel to patch that in. It's fairly straightforward. So in extended BASIC, I printed the comments file from my program up at 6E1. So 6E1 is the where it's doing an input, where it's doing output. There's all output goes to one spot here at 6E1. And we want to change this to jump to our EPROM code. That entry point is F9DA. So we want to put a jump here. So we'll deposit the jump, and we want it to jump to F9DA. So the DA goes in first because of little endian. So there's the DA, right? DA. So deposit next. DA and F9. F9. F9 looks right. That's it. So all I did was change that to jump to the output routine that's inside this EPROM. And now BASIC always just runs from 0. So it's pretty easy. I can just get BASIC back by doing a reset and hit and run. All right, so we've got our OK prompt again. Now, for those of you who've used Cutter or Solos or the processor technology products, you know that the VDM board and the Sol20 can pace the rate at which characters can come out. They can come out in slow motion. So he did that. So to save yourself problems later, you go ahead and poke his variable, which again is way up at the top of RAM, and set the display rate to be full speed. And then to initialize the driver and clear the screen, you send the driver an ASCII 2. Now, that's going to go to the screen. If I want it to go to the VDM board, I have to now put up sense switch 0. I'll just put these down for the hell of it. So sense switch 0 is now up. So this print statement's going to go to the VDM board, and you'll see it initialize everything. All right, so now I'm typing on the keyboard. I don't know if you can see the screen or not. So print 2 + 2. All right. So now everything's coming to the VDM board instead of over on your slow teletype at 110 baud. Now, you can change the speed. I'm the type digits on the character. So if I type a 9, you can see that's really a slow pace. A 7 is a little bit faster. 5 is faster. So this was that pacing variable I said at the beginning. If you had some random number and variable in memory, who knows what it would be. But I can run that again, and I'll flip sense switch 0 now. You'll see it go back and forth. Anyway, so pretty simple. The guy had a teletype, and now he's doing it all on his VDM board and doesn't have to wait on that slow teletype to do everything. Now, the other thing you might have noticed is I have these inverted characters, which is pretty annoying. Inverted video on a VDM1 is due to the fact that the most significant bit is set. And these old basics set that bit on all keywords on the last character to indicate end of the keyword. That's how it determined it. And I'm really surprised he did not and that off in this code, but he didn't. Maybe he likes seeing the keywords. I don't know. Anyway, so I'm going to show you something that you probably never realized that the flex board can do. I can reprogram this EPROM on that Flex 64K board from the front panel without having to load anything. You can just go in and do deposits. So all I really want to do is where it's jumping to this VDM routine within the VDM code, I want to do an AND before I do that. So just 2 bytes. I'm going to do an AND with 7F. So I'm going to go into this VDM board and I'm going to turn on the programming switch. Okay, so now the right line is enabled. So I'm going to stop the computer. And what I want to do is change F9ED. So F9ED. Whoops, what am I doing wrong? F9ED. All right, so right now there's a jump. That's what that is, back to 00F9. That's where the VDM driver starts, is the very beginning of that prompt. What I want to do is do an AND immediate with 7F first to get rid of that most significant bit, and then jump to F900. All right, so AND immediate is an E6. So let's see what I got here. E6, that's right. And then 7F. So 7F, that's good. All right, so now it's done the AND immediate 7F, and now I do the jump to F900. Let's C3. And 00 goes first, followed by the F9. F9. All right, so I actually just programmed the Flex 64K EEPROM. If you did that without flipping the switch, the values wouldn't change. Let me put the switch back. So for example, I could set these to 0, start doing deposit next, and it's working for some reason. Or maybe there was zeros there. What did I do? Yeah, I don't know why that's depositing at the moment. Oh, it's not. Happened to be zeros there, I guess. So it's not depositing what's on the switches. So anyway, yeah, you can actually reprogram a few bytes in your EEPROM if you want without having to do anything but use the front panel. All right, so now let's run basic again. And I should no longer have ugly, yeah, see now they're all gone because I handed it off. So anyway, I found that insanely cool that guy did that way back when. I'm assuming he had some sort of tool or assembler or something to help himself because it wasn't a small program. It would be hard to hand code all that. But he probably had access to something at work or something like that. But anyway, I was impressed. I liked it.
Hey, Mike,
Uh-huh.
can you do the overview of what boards are in the computer again? And the first start up to examining F8. Because
Well, it's the 8080 CPU. And then you could have an 88 PMC EPROM board and RAM. I just used a Flex 64K board. So that the EPROM is at F800 and F900. Those are the 2 EPROMs. And then he had 20K of RAM in his system. Of course, you could easily patch those EPROMs to use a 2SIO or to have more RAM, whatever you wanted. This is a VDM1 board. This is the one the guy did that's an identical schematic, all the same part identifiers. I got this from you, Walt.
Yeah.
It's just a different circuit board layout using modern programs. So you don't have the ribbon cable and you actually got the connector on the board. And then I'm using a, just draw a blank. not a 4PIO, IO4 board. There we go, to do my SIO. And what else did you want to know?
Well, and then from there you went to the Examine F8, right?
Yeah, if he turned on his computer for the day, he would do a reset, and if he wanted to boot extended basic, he would do that and hit run. That's it.
Right. Okay, that's what I needed, because my recording program started 5 seconds after you had started.
Oh, gotcha. All
And
right.
Joe's mic is on. See, Joe, when you turned your mic on, it erased the picture of Mike's computer and put your face on the screen.
Funny because I didn't say anything, but okay. Sorry about that. I turned it on. I was going to ask a question at the time, but I thought we were done. So sorry about that.
Yeah, no, but I'm just saying that was at the end of it anyway, but that's what I'm saying. That's why I asked everybody to mute the mics.
Mm. Very cool, Mike. Very cool.
Yeah, I thought that was a cool. Yeah, another guy's got a really old Altair complete with original sales receipt. It was one of the ones where it was only 395, or whatever the very, very first price was. So he had a very early one. So it's pretty neat setup. He's working on getting going again.
Cool. Yeah, thanks for sharing that. That is pretty cool stuff.
Thanks for sharing, Mike.
Yep. All right. Was that the excitement for the day?
That's all I have and all you have, I think. So unless somebody else has got something. Come on, guys, top it. Start challenge dropped.
I want to show Walt's new game. It's actually, if I can get my fingers to work right,
Yeah.
it's actually pretty good.
Oh,
Is this the multiplayer Pong?
Yeah.
That SpaceWar game, that's tough. I actually got up to eight hits on computer target, but I haven't been able to get to 10.
I don't know if you guys can see that.
Yeah.
But yeah, he did this. It uses the Dazzler. So that's the hard part.
Oh God, yeah.
It's a lot of keys, but so I just figure if I can just do an H, he'll eventually fly in front of me. But anyway, so I don't know if you guys have seen SpaceWar on the gosh, what is it? This for the SAW, what's that? VDM1?
Yeah.
So this is Walt's Dazzler version. It's actually kind of cute. But I just can't do the keys enough without flying into the sun.
Yeah. But if you go to the Computer History Museum in Mountain View, you can play this on a PDP-1.
Well, that's the idea. This is for those of us that don't go to the Computer History Museum.
Well, I mean, you can also buy one of the Pi DP ones, and it will play this. But yeah, seeing it played on a real PDP-1 with the real round radar display, basically for the screen, was something else. I'll tell you.
Yeah, I need to get it to work with the joystick, because then I could probably play.
That was one of my things I was thinking about. Should I if I add a joystick operation, I think I would rather add USB joysticks from your computer.
Yeah, that's what that's what I have hooked up to my computer, is just USB joystick.
Yeah, because then everybody's got at least one old USB joystick.
Yeah.
Anyways, it's cute.
Yeah, that's cool. Good job.
So you want the USB joystick to talk to the virtual Dazzler, okay, in the simulator.
Well, it'll talk to the real Dazzler too.
Well, that's a little trickier. That's
Yeah,
actually trickier.
yeah, no, 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 there's what is it, A7, whatever it is. There's joystick in the simulator, but Walt needs to add it to his program to
Yeah.
read it. If the joysticks, you do the joystick or a keyboard.
Yeah.
Yeah, I mean, it seems to me, since, because I use TerraTerm on my computer for a console to my computers, Altairs. So I figure that I should be able to use a USB joystick to connect to the same signals going in through the console, since that's on a USB cable anyway.
Um,
Windows should be able to patch it in.
well, you'd have to write some software that converted whatever the joystick's sending into key presses, basically, is the way you'd have to do it. Because the joystick itself is not sending keys. It's, it's doing its own thing. So you'd have to write a piece of software to read the USB joystick and generate what you want to send through TerraTerm. And then you also got the challenge of, in most environments, you can only connect one thing to a USB port. So your serial USB is going to be connected to TerraTerm. So what you would have to do is have the joystick pretend to be another keyboard and send the appropriate keys. Claude can write that for you.
Oh yeah.
Well, that's the idea, is instead, because once you start the game, hit a button on your joystick or hit a key on the keyboard to tell it to read the other port. So you tell the game you got two different COM ports, and then switch over to the joystick COM port, and then
Oh, I see. Yeah, you're still going to have to write some software to convert whatever the USB joystick sends.
yeah, that's in the game.
Wait, well, no.
The
You
game
have
would
to.
just read the joystick. You would set up your joystick. It would test the joystick. Go upper left, down right, upper right, down left.
Yeah, but hey, while you're running this, what are you running this on? The Arduino or your 8800C?
I'm running it on Altair 8800 with the Dazzler.
Yeah, it has no USB interface to read the joystick.
Well, yeah, it's got a COM port. It goes through the COM port on the Altair.
Right,
Yeah,
but
yeah, that's what Tim's saying. You'll have to do something that converts the joystick signals to
key
a
presses,
serial
basically.
to basically to a serial port.
Yeah,
No, when you run the joystick and the USB out the other USB, you just get a bunch of numbers, but they change as you move your
right.
joystick around. So all you have to do is have the pro game read those joystick things, say upper left, upper right, bottom left.
How you going to read USB on your Altair?
Yeah, how are you going to read the USB on the Altair? That's what I want to know.
Yeah.
Well, because it goes through the serial port on the Altair to the USB to serial
So how
port.
are you?
No. USB joysticks don't work that way. You need to have a hub and everything.
No.
Yes.
That from the Altair to my PC is a RS-232 to USB converter.
Right.
Yeah, so you have to convert, you have to take the input from the joystick, do a conversion, and send it out the serial port.
Right.
Now like we were working with like Tim on Unix, you could probably just say, hey, hook them together and it just works. But on Windows, you probably got to do some
Yeah, you have to do yeah, and you may have to do some translation in the middle as well.
Yeah.
But yeah, you're going to have some software that connects the two USB ports in your PC because that's not native to Windows.
Yeah, but it's kind of a good idea though to convert a joystick to